So guys, in today's video we are going to look after a concept called as emulsions. So basically when we were doing the classification of the colloids, there we have seen our type of a classification depending upon your physical states of your dispersed phase and a dispersion medium. Of course we came to know that whenever the dispersed phase and your dispersion medium, if both are in that of your liquid phase, both are in the liquid state, then such a colloidal system is called as your emulsions. So how can we define an emulsion? So an emulsion is a colloidal system. An emulsion is a colloidal system in which both dispersed phase and dispersion medium, are liquids. So this is called as what? Your emulsions. So what do you mean by an emulsion? It is a colloidal system in which both your dispersed phase and your dispersion medium are liquid. So now the question arises, what is the thing we have to understand over here? Remember guys, so whenever we are taking a two liquid, that is your dispersed phase is also a liquid phase and that of your dispersion medium is also a liquid, there is a possibility that both the liquids are immiscible. Both the liquids are immiscible. That means what? Immiscible means what? They both are not forming an uniform concentration. Instead, they are forming an heterogeneous system. So depending upon this heterogeneous system, we have been classifying our emulsions into two types. One is called as, first one, oil in water type emulsions. Oil in water type emulsions, which is also written as O bar W type. And the second one, it is called as water in oil type emulsions. Water in oil type emulsions, which is called as what? W bar O type. Yes. Now the question arises, what are the different types of your emulsion suggestors? So let us first of all deal with the first part, that is oil in water type emulsion. Remember, in the first classification of your emulsion, it says that in the first part your oil is in the dispersed phase. Oil is the dispersed phase and water is in the dispersion medium. That is the reason we call it as what? Oil in water type emulsion, or it is also called as O bar W, which means oil in water type. Yes. So in this scenario, what we are saying is, first part, oil is the dispersed phase and water is the dispersion medium. What are the examples if you ask me? It could be your milk, it could be your vanishing cream. So basically, now the question arises, can you please explain me, sir, how can we consider your milk as a type of oil in water? Remember, milk is an emulsion, which why we say it is an emulsion, because here liquid fat is dispersed in water. Liquid fat is dispersed in water. So here liquid fat suggests what? Oil. Whereas dispersed in water, of course, oil in water, which is an example for milk. Why? Because your liquid fat is dispersed in your water. That is the reason milk is an emulsion. Milk is an emulsion, and why we are calling it as an emulsion particularly because here the liquid fat is dispersed in water. And in particular, if someone asks you what type of an emulsion your milk is, you should very much specific that it is a type of oil in water type emulsion. Okay, why? Because your liquid fat will be dispersed in your water. Of course, the second part, now you can only guide me. Yes, since in the first oil was in the dispersed phase, water was in the dispersion medium. In the second, what is it saying? Water in oil type emulsion means here water will be in the dispersed phase, or water is the dispersed phase, and oil is the dispersion medium. Oil is the dispersion medium. Alva. So you just make a close knowledge over here. So your water is acting as what? Dispersed phase. Whereas oil is acting as that of your dispersion medium. Example, if I may just give you butter, whatever the butter we are using, or the cream, butter, cream. So water will be the dispersion medium, and whereas that oil content, you have just touched it, alva, it will be like a soapy material, like somewhat like a slippery. So that oil will be your dispersion medium, whereas water will be your dispersed phase. But the most common example for the water in the dispersed phase is that of your cod liver oil. Many times they have asked it. Cod liver oil is an emulsion of water in oil. Okay, is an emulsion of water in oil. So we have studied that emulsion is an colloidal system in which both your dispersed phase and a dispersion medium are a liquid. So they are mainly classified into two types, and we came to know that both the liquids are immiscible, then it will be resulting in an heterogeneous system. Immiscible and artha eno ondukkondu serta illa. They are keeping it apart. Okay. So mainly the emulsions are classified into two types, that is oil in water type emulsion or O bar W type. What does it mean? So in the first case, oil will be acting as a dispersed phase and water will be acting as that of your dispersion medium. Example is that of your milk and vanishing cream. So when I am particularly concentrating about my milk, how can I say it is an emulsion and particularly that of your oil in water? Because when we are seeing the milk, there we could notice that it is an emulsion in which your liquid fat will be dispersed in your water, where your liquid fat act as your oil and similarly the solvent, water will be acting as its dispersion medium. Coming to the next part is called as what? Water in oil type emulsion, which means what? First whatever we are writing, it will be acting as what? Water is the dispersed phase, and similarly oil will be your dispersion medium. And common examples are butter, cream, and the most common example is your cod liver oil. How to remember it? Remember. So we know that there are two types, O bar W, W bar O. So whatever we are writing first, it will be your dispersed phase. Second, whatever it is coming, it is your dispersion medium. But the common thing you have to remember those examples. Milk is an example of oil in water. Why? Liquid fat will be dispersed in water. Similarly, water in oil, cod liver oil is an example. Here what is happening? Here water is dispersed in oil. But when we are talking about this emulsion, of course I have mentioned there what? It is an heterogeneous system. That means what? If I am taking a two liquids in an emulsion, what happens? Here one liquid will be having one surface and the another liquid will be on top of it. That is means what? They are not coming in they are not being mixing up. So such a mixing up, so when such two liquids are not mixing up, that will be resulting in an unstable condition. Unstable condition. In simple words, when the two liquids are immiscible, they will be separating into two different layers. Alva? When they are standing, they will be separated into two different layers. So therefore what happens? Certain times it becomes an unstable emulsion. So in order to stabilize such emulsions, we add an agent. What we are adding? So in order to stabilize certain emulsions, what we add certain substances. So that the substances are called as what? Your emulsifiers or your emulsifying agents. Emulsifiers or your emulsifying agents. So actually what they do means they are acting to reduce the interfacial tension between the two liquids. Interfacial tension between the two liquids. So now the question arises, as soon as when I say that, okay, whenever you are adding an emulsifier and emulsifying agents, what happens? The two immiscible liquids become miscible. But now the question arises, how? So basically when you are adding such emulsifying agents, what they do means, they are acting in such a way to reduce the interfacial tension between that of your two liquids. So when such interfacial tension decreases between the two liquids, easily two immiscible liquids become miscible. So how can we define this emulsifier or emulsifying agents? The substances added to stabilize the emulsions. The substances added to stabilize the emulsions are called as your emulsifiers, or emulsifying agents. So how can you define it? The substances added to stabilize the emulsion are called as your emulsifiers or your emulsifying agents. And how they are doing it? By reducing the interfacial between the two liquids. Common examples, if you just see, when you're seeking the type of OW type emulsions, the better emulsifiers could be your proteins, yes, your gums, and similarly your natural and synthetic soaps. So in an OW type, oil in water, for example milk and vanishing cream, in order to stabilize such OW type emulsions, what we can add as an emulsifying agents? Your proteins, your gums, your natural and synthetic soaps. Similarly, when I am coming with respect to the WO type emulsions, remember here your heavy metal salts of your fatty acids, similarly your long chain alcohols, and etc. we can add over. Similarly, we also say a lamp black. I don't know how many of you know it. So it is also an emulsifier agent, lamp black, which is an acts as that of your emulsifier or emulsifying agents of your WO type. Okay. So in this scenario, now this common thing which strikes our brain. Of course, this is a part which we have seen as per your board. Now the question arises that, how by seeing certain liquid system we can distinguish that it is an OW type and WO type. Of course, it's not included in your syllabus, but I would like to mention it. So remember guys, whenever we are talking about your OW or WO type system, we are mainly doing certain identification test, which is mainly classified into three types. First one, it is called as what? Your dilution test. What it is called as a dilution test. Basically what we do, so for our whatever the given emulsion is there, okay, when the emulsion they have been given you, when the emulsion quoted, so what to that emulsion I will be taking small amount of that emulsion, and to that I will be adding some few drops of water. So few drops of water is added to the given emulsion. So when I add it, what happens basically? If the water added mixes completely, remember such an emulsion will be called as OW type emulsion. Is one of the test, dilution test. And whatever the emulsion they have given you, to that you add just few drops of water, and you just observe whether the water becomes completely miscible with that emulsion. In such scenario, if it becomes completely miscible, then that part of a system of emulsion is called as what? OW type emulsion. The second test, generally what we do is your conduction test. So in this test, what we do is we add some amount of electrolyte. So when we add that electrolyte, then we check out its conductance of your emulsion. So if the conductance increases, once again it will be called as your OW type emulsion, which is a test called as a conduction test. So what we are doing, a small amount of your electrolyte is added to the given emulsion, and if the conductance increases after the addition of the electrolyte, then such an emulsion will be called as your OW type emulsion. The next important test, which is called as that of your dye test. Dye test. So here what we do is basically we are choosing a dye which will be soluble in a oil, or we can say it's a oil soluble. So we will be choosing a dye which will be soluble in oil, and when it is added to the given emulsion, and if the emulsion becomes deeply colored, by the addition, in simple words, if I had to say, by the addition of your oil soluble dye to the emulsion, if the emulsion becomes deeply colored, remember at that moment it is called as WO type emulsion. What it is called as WO type emulsion. So in the first two cases we saw, when you are adding the water to your emulsion and it becomes completely miscible, that is water is completely mixing, then it will be called as your OW type. Similarly, in the conduction test also we saw, when you are adding some amount of electrolyte, you are measuring the conductance, and if the conductance increases, then it will be called as your OW type. But with respect to the dye test, when you are adding your oil soluble dye to that of your emulsions, and if the emulsion is becoming deeply colored, so such an emulsion will be called as your WO type emulsion. So these are the certain things one has to know. How we can say that, how can you classify your emulsions as OW type and WO type. Coming with respect to the properties of emulsion, do remember your emulsion exhibit all the properties like your Tyndall effect, your Brownian movement, and also your electrophoresis. So your emulsion exhibit all the effects, that is your Tyndall effect, your Brownian movement, your electrophoresis. Similarly, the next important property, remember, your emulsions, basically they will be carrying the negative charges. Okay, since the droplets of emulsion often carry a negative charge, basically, these emulsions can be coagulated. Hinge coagulate material by the addition of your suitable electrolytes. So first important property we saw is what? Your emulsions exhibit all the properties like your Tyndall effect, your Brownian movement. Emulsion exhibits all types of your effects. That could be a Tyndall effect, your Brownian movement, and electrophoresis. Coming with respect to the charges, your emulsion also carries some negative charges, so they can be easily coagulated by utilizing your electrolytes. Now when the question arises that when you are having the two liquids as immiscible, can we extract the two separate liquids out? Can we separate the two liquids within an emulsion? Of course, yes, we can separate it. That is by your heating, your freezing certain times, or also your centrifuging. So these are the methods which will be applied in order to extract the two different liquids within an emulsion. So when we are extracting or when we are separating the emulsion into two constituent liquids by your heating, freezing or centrifuging, so that process will be called as your de-emulsification. What it will be called as? It is called as de-emulsification. So what is de-emulsification? Basically the emulsion separated into constituent liquids by heating, freezing or centrifuging. That process is called as your de-emulsification. So these are certain properties which is exhibited by the of your emulsions. So basically we came to know till now that your emulsion is a colloidal system which is having both your dispersed phase and your dispersion medium as the liquid. So mainly it is an heterogeneous system if it is consisting of that of your two immiscible liquids. Yes. And broadly they are classified into two types, that is your OW type, that is oil in water, where your oil will be the dispersed phase, water will be your dispersion medium. The common example is that of your milk. Why milk is called as an OW type emulsion? Because the liquid fat will be dispersed in that of your water. Yeah. Similarly, vanishing cream is also an example of your OW type emulsion. Coming to the another classification, it is called as WO type emulsion, where your water acts as your dispersed phase and oil as your dispersion medium. And there we came to know that your cod liver oil is a better example, and also your butter, where your water is dispersed in oil. And we came to know that in order, since whenever you are using your emulsions, basically if they are made up of the pure liquids, if the emulsions, whatever you have been prepared, if they are made up of a pure liquids, they will be generally unstable, or they are generally not stable. So not stable means what? Whatever the two liquids you have taken, they will be immiscible. That is, they will be separated into the two different layers on standing. So in order to make them miscible, we add certain substances. So that added substance, in order to stabilize your emulsions, they are called as your emulsifiers or emulsifying agents. Once again I repeat, whenever you are using your emulsions preparation, or whenever you are preparing your emulsions by the pure liquids, so they are generally not stable. So in order to stabilize such emulsions, what we add certain substances which stabilize your emulsions, and those substances are called as your emulsifiers or emulsifying agents. The common emulsifying agents for your OW type we have seen, that could be your proteins, gums, etc. And that of your WO type, it is your heavy metal salts, or that of your long chain alcohols. Yes. Then we also saw certain important aspects, that how can we say that which of your emulsion is an OW or a WO type? By doing certain test, that is your dilution test and that of your conduction test. If both the test gives us the positive, it results in that of your which type? OW type emulsion. So if the dye test is giving us a positive result, it will be giving us information that the given emulsion is a WO type. Coming with respect to the properties, we saw that emulsion exhibits all type of the properties, that could be a Tyndall effect, Brownian movement, electrophoresis. And similarly, your emulsions are having the negative charges associated with it, so they can be easily coagulated by using your electrolytes. And similarly, when we are having the emulsions, we know that they are having the two different liquids. So when the question arises that can we separate those two liquids within an emulsion, of course we can do it, and that process is called as your de-emulsification. Okay. So in this video, now we are going to see that where and all, soon after we have completed the emulsion, in the next part we are going to see a general thing where we are generally seeing this colloidal nature, where our colloid is surrounding us. Okay. So guys, now let us see that how does the colloid is surrounding us. How is our colloid is surrounding us, whether in day-to-day life, whether we are seeing certain colloidal particles in and around us. Remember, the first important concept of your colloid, which nature has gifted us, is the blue color of the sky. Blue color of the sky. So basically what happens generally, it is mainly because of the scattering of the blue light, scattering of your blue light by the dust particles, which is present in the atmosphere, also along with the water suspended in air. We are observing the color of the sky to be blue in color. So how can we judgmentally give in with respect to the of your physicist phenomenon? Basically it is given by that of your Rayleigh scattering. Rayleigh scattering. So what he says is, actually he is very much particular about the size of the particles. He says that if the particles are smaller, what he says, if the particles are smaller than the wavelength of the incident radiation. What is he saying? If the particles are smaller than the wavelength of your incident radiation or incident radiation, then he says that the intensity of the scattered radiation is inversely proportional to the fourth power of your wavelength. So this is according to your Rayleigh. So in here, whenever the particles are size, that is your colloidal particles, we can have to assume, when they are much smaller compared to that of the wavelength of the incident radiation, what happens? Whatever the scattering intensity is there, it will be inversely proportional to the wavelength. So using this concept itself, we can easily say that why does your sky appears blue? Since the blue color of the white light has a minimum wavelength, it shows what? More intense scattering. Since whatever the blue color of the white light is there, it is having a minimum wavelength. So that will be what happens according to them. Since the wavelength is minimum, the intensity of your scattering light will be more. And that is the reason your sky appears to be blue in color. Similarly, the food particles we eat, that could be your butter, your ice creams, your fruit juices. So they are all colloidal in nature. Remember, whenever you are eating your ice creams, even your halwa mithai, whatever we are seeing, they are all colloidal in nature. Similarly, coming with respect to that of your fog and mist, yes, as I have explained, they are also what? Colloidal in nature. So how can we say fog, mist and even rain, they are all colloidal in nature? Yeah, there are. Basically in winters, what happened at night time, the moisture of your air condenses on the surface of the dust particles. So that dust particles, what happens? They will be forming like a fine droplets. So that droplets, what they will be? They will be colloidal in size, and they will be continually floating in air in the form of your fog or your mist. Similarly, your clouds, whatever we are saying, the clouds, they are an examples of your aerosols. So they will be having the small droplets of the water suspended in air. So the colloidal droplets of the water, then they will be growing in size, and due to condensation in upper atmosphere, finally leading to your rain. Even when two oppositely charged clouds meets, your rainfall occurs. Alva. An artificial rain, which is very much important in the present scenario. How it is caused? Basically your colloid, that is your aerosol clouds, they will be having certain particular charges. So when the clouds bearing these particular charges, they have been thrown with respect to that of your electrified sand. So these electrified sand, what happens? They will be having an opposite charges. So how can we pour this electrified sand? By using your aeroplanes. But the common thing what we have to notice over here is your clouds are also having the specific charge. The electrified sand what we are pouring, that will be having an oppositely charge. So mutual coagulation takes place, finally resulting to that of your rain, which is an example of your artificial rain, which is a process which is carried out in your artificial rain. Similarly, your blood is also colloidal in nature. Yes, so whenever you get a hurt, blood fuses out. But soon after some time, it gets coagulated. How it is being coagulated? Since blood is what it is, it's a negatively charged colloidal particle. But when your blood is fusing out, at that moment of time, your alum and that of your ferric chloride act as a coagulating agent of your oppositely charged. And soon after, it coagulates your blood. That is the reason blood doesn't continuously flow out of your cut or hurts. Why is it so? Because oppositely charged your ferric chloride or your alum is coagulating your blood there itself. Similarly, your soils, whatever the soil we see, basically your fertile soils are colloidal in nature. And we say that whenever a humus is present, it is very much important for the soil. Yeah, okay? Because there your humus acts as a protective colloid. And this protective colloid, what does it do? It makes the fertile soil not to get coagulated. Instead, it makes the fertile soil to be colloidal in nature. And when it is colloidal in nature, it becomes very much important for the soil and very much easy for the soil to absorb the moisture and the nourishing materials. Similarly, when we are seeing in rivers, we are seeing a delta region. That is, we can see certain sand particles have been come near that of your reverse part. That is called a delta region. So how it is formed? Basically what happens means river water carries a negatively charged clay and sand particles. What you are having? Your river particles, they will be having a negatively charged clay and the sand particles. So at that moment of time, what happens? Where the river meets the sea, basically, where your river meets the sea, the electrolytes of your seawater, like that of your Na plus K plus, Ca2 plus. So what they cause, here the coagulation takes place. And when such coagulation takes place, what will be happening? Your sand and clay will get scattered at that region. And that region will be called as your delta region. So how is this delta region is formed? It is also one of your colloidal phenomenon itself, coagulation. So whenever your river is there, they will be having your negatively charged clay and that of your sand. When it is coming and meeting that of your seawater, basically, there we are having some positively charged electrolytes, mutual coagulation takes place, and your clay and sand get spreaded over, which itself is called as your delta region. So these are the certain scenarios which we have missed in our day-to-day life without knowing the phenomena. So now onwards, whenever you see certain things, whenever you get a hurt and your blood is diffusing out, and soon after it gets clotted out, you should come to your know, okay, this is a colloidal phenomenon. Whenever you are eating a butter, it should come to your brain, yeah, it is a colloidal in nature. Similarly, the fog, mist, rain, they are all colloidal in nature. Soon after, when you raise your head and see the sky, the blue color of the sky should remind you, oh, it is a colloidal phenomenon according to the Rayleigh scattering. Remember, the particle size should be less than that of the wavelength of the incident radiation. Then only maximum intensity of the scattering is observed. Okay, so these are the certain phenomena of the colloids which we are seeing around us. So in our next video, we are going to see that how can we use the colloid for the betterment of our generations and also for certain industrial purpose. Okay, so in the next video, we are going to see the application of the colloids.